Hello students, welcome to mathematics class. Students, this is part 3 of the chapter Algebra. In this part 3, we will see the uses of variables in forming common rules, and later we will solve the questions from exercise 11.2. Coming to the use of variables in forming or in making common rules or generalizations. Normally rules from geometry such as the perimeter of a square. You know, in a square of the side L units, if you want to find perimeter, you will find by taking this variable. Here the L units is variable which represents some number. So, we have another example. If you want to find out area of a rectangle, you will use its length and breadth with the variables such as L and B. Therefore, we find perimeter of a square or a area of a square in terms of a letter such as L, or some other variable you can take even x also, and even perimeter of a rectangle in terms of L and B, or area of a rectangle in terms of L and B, we can express, which normally called formulae. They are generally rules of geometry by using variables are formed. See, I am going to write them as examples. Perimeter of a square, area of a square, of the side L units will be 4 times L. You could watch this 4 times L is again algebraic variable used here, and L square units. Square units means centimeter square, meter square, kilometer square, like that, are examples for the rules of geometry. Okay, they are the rules. Even when it comes to the perimeter of a rectangle, so it is of a rectangle, 2 times of L plus B, that is also a rule or a formula formed with the help of variables. And even area of a rectangle of length L and breadth B will be L into B. So, they are all rules from the geometry. Now, children, going to the another important, we use variables in forming rules from arithmetic. What are the rules from arithmetic that you have learned? Are, let us say, are properties. So, properties, oh sorry, here properties, properties of arithmetic that you have learned, properties of numbers. What are the properties of numbers that you have learned? Commutative property. So what does this commutative property says? Under addition. So commutative property under addition says when a number is added to the other number in whichever the order that they are added, whether b is added to a or a is added to b, the sum remains same. Here you are using the variables a and b, they are variables only. So you are forming commutative property with the help of variables. Even distributivity. So distributivity also says when variable x multiplied over the sum of two variables, that is we say a number multiplied over the sum of two numbers will be distributed. So x into y plus z is xy plus xz. We learnt it as multiplication over addition, distributivity, multiplication over addition. Here again I am using variables x, y and z. So these are the use of variables where we use them in forming or in making formulae, in geometry or properties in arithmetic. Now children, coming to the questions of exercise 11.2. In exercise 11.2, main question number 1. The side of an equilateral triangle is shown by L. Express the perimeter of the equilateral triangle using L. So in an equilateral triangle, we know that all sides are equal. If one of the side is L units, then all the sides becomes L units. Therefore, perimeter of an equilateral triangle with the side L will be 3 times L units. Children, you know how it has come? It is because when we add L for 3 times, perimeter is nothing but total length of the boundary. So that means L added to itself for 3 times. So L added to itself for 3 times, nothing but L plus L plus L, that is 3 times L. That's how this 3L has come. Now coming to the main question 2. The side of a regular hexagon, hexagon nothing but 6-sided closed quadrilateral. So in this hexagon there is a one speciality, it is a regular. What is the meaning of regular? Regular means all sides are equal, and not only sides are equal, and all interior angles are equal. You will come to know clear definition once you come to higher classes. So it is a regular hexagon. So in this regular hexagon, each of its side is L units. So express the perimeter of that hexagon using L units. So very simple, as I have already told in the case of equilateral triangle, perimeter of a regular hexagon of side L units will be L added to itself for 6 times because perimeter is nothing but total length of the boundary. So L added to itself for 6 times, which gives 6 times L units of length. If it is in centimeter, L centimeters, we say 6L centimeters. If the L is in the units of meters, then we say 6L meters. So units very important when it comes to the mensuration chapter. So don't forget centimeters or meters, kilometers, liters, milliliters, seconds, minutes, hours. Writing that units, do not miss it out. Now total length of the boundary of this hexagon, regular hexagon, will be 6L, which we call it as perimeter of this regular hexagon, 6L units. Now coming to the question number 3. In this question number 3, a cube is a 3-dimensional figure as shown in this figure 11.11. It has 6 faces and all of them are identical squares. The length of an edge of a cube is given as L units. Find the formula for the total length. Here L is missing. For the total length of edges. Now tell me first of all, how many edges are there in this cube? Can you count them? Yes. Here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 edges. Children, remember, in a cube, how can I find that quickly? Remember, it is a 3-dimension. You have got totally lengths and breadths and heights. So along the lengthwise you have got 4. Along the breadth, here I am showing you lengthwise. Along the lengthwise I have 4. Along the breadthwise I have 4. Along the heightwise I have 4. So totally along the length 4, along the breadth 4, along the height 4. Total 12 are there. So perimeter, or the you can say total length of the edges of this cube is 12 times of L, because there are 12 edges. Okay, as there are 12 edges, okay, which you have to remember. Then coming to the main question number 4, the diameter of a circle is a line. Diameter means it's a circle. The diameter of a circle is a line which joins two end points on the circle and also passing through the center of that circle. In that joining figure it is shown AB is the diameter of the circle, C is the center. Express the diameter of the circle D in terms of radius. See children, very simple. From A to C, one time radius. From B to C, one time radius. You know what is radius? Radius is the distance from center of a circle to any point on the circle. So diameter D of a circle will be 2 times the radius of a circle, because r plus r 2 times the radius of that circle. You know how to write it, you have learnt already this formula. So write it properly. Now coming to the main question 5. In the main question 5, to find the sum of three numbers 14, 27, 13, we can have two ways. We may first add 14, 27 and get 41 and then add 13 to it, get the sum as 54, or we may add 27 and 13 to get 14 and then add 14 to get the sum as 54. Thus, 14 plus 27 plus 13 is equals to 14 plus 27 plus 13. Do you know what is this property? This property is called associativity under addition. So children, associativity under addition says you need to generalize this with the help of variables. So how do you generalize? A plus B plus C equals to A plus of B plus C. So this is the associativity of addition, which we have generalized using variables instead of numbers. So we have asked to do that. Students, this is how we can generalize this explanation of sum of any three numbers. However they are added, their sum remains same using variables. So we formed a rule in this regard, and this rule is called associativity under addition. Once again I'll repeat, associativity under addition says sum of any three numbers, however they are added, is same, is equal. We could represent with the help of three variables. A plus B plus C is equals to A plus B plus C, where A, B, C are, where A, B, C are, you can say natural numbers, or you can say any other type of numbers. Children, with this I will wind up this session. We will learn next session expressions and variables. We will learn forming an expression in our next class. So till then, take care of yourself. Jai Hind. Thank you.